Alright, so continuing Chapter 1, Section 5, the second part. It's solving quadratic equations by completing the square. So when you complete the square, certain rules have to apply first. The coefficient of the x squared term has to be a 1, and you're going to have to boot the constant to the other side. But you for sure have to make sure that the leading coefficient is a 1. If it's not, then you have to divide all the terms in the equation by that value to make it be a 1. Completing the square is a technique that forces an equation to become a perfect square trinomial. That way, when we factor it, we get a single binomial squared, and then we can use the square root method to find our zeros or our x-intercepts or our solutions. So it's a technique that forces an equation to become a perfect square trinomial. So, number 1, when you are completing the square, the coefficient of your quadratic term, or we'll say of the x squared term, which is our quadratic term, must be 1. You can't do complete the square unless that's a 1. The second step is you boot the constant, which is the term in your equation that does not have a variable. That's your constant term. So you boot the constant to the other side. You know, we use boot. You know, like if you give someone the boot, it means you're kicking them out. Okay, so we're kicking the constant out. We're telling it to go to the other side of the equation. So you boot the constant to the other side of the equation. The next step is to take 1/2 the coefficient of the linear term, or the x to the power of 1 term. Okay, that's your quadratic term, this is your linear term. So you take half the coefficient of the linear term, comma, you square it, and then you add that value to both sides. That's your square, right? You're adding a square to both sides. So, and add that value, or it, to both sides of the equation. Once you do that, you add it to both sides, the left side of the equation becomes a perfect square trinomial, which you then need to factor. And those always factor as a single binomial squared, and that's why when you're doing all that homework where you're factoring perfect square trinomials, I wanted you to write it as a single binomial squared because it leads into this. Factor the perfect square trinomial. Okay, and after you have that perfect square trinomial factored, you're going to end up with one quantity, a single quantity squared, and that's where we're going to apply the square root method to finish solving. Okay, complete the square works with everything. It helps us with polynomials that are prime and can't be factored. So it helps us get those zeros. Sometimes we will have imaginaries, which is why we did the lesson on I before we do this lesson. Alright, so our first example in this section. It says solve by completing the square. Again, read the directions. If it says you have to use one method over another, then you must use that method. Now, complete the square is beautiful because you can use complete the square with any polynomial that can be factored. And I believe, no, scratch that, I don't believe. All right, x squared subtract 2x subtract 2 equals 0. So I look at this and I'm like, I wonder if I could factor this. So I need two numbers that multiply to 2 that when I subtract them give me a 2. That's not possible. And so what I have to do, I have to complete the square. Notice the leading coefficient, or the coefficient of your quadratic term, is a 1. So I have less work to do here. So the next step is to boot the constant. The constant is this, -2. Boot it to the other side. So I got x squared subtract 2x equals positive 2 now. You see, I took this 2 and I just moved it over to the other side. Now I have to take half of the coefficient of the linear term, this middle guy. Okay, so half of means multiplication in math, half of -2 equals -1. And then you have to square that -1. Okay, so comma, -1 squared is 1. Now this is the square that I add to both sides. So I've got, and I'm going to do plus some square plus some square. So you have to keep the equation balanced. So I have to add that square to both sides. The left side becomes x squared subtract 2x plus 1 equals 2 plus 1. The left side is now a perfect square trinomial that's always going to factor into a single binomial squared. Over here I'm just going to add these. 2 and 1 is 3. Now, I get two polynomials, signs are the same, they're both negative. How do you get these two? Well, you just take the square root of those, just like we did before. This is x, this is 1, sign is minus. So I get a quantity x minus 1 squared equals 3. Take the square root of both sides, you get x minus 1 equals positive or negative, the square root of 3. And then move the 1 to the other side, I get x equals 1 plus or minus root 3. That's two solutions. Now, technically, at least on a calculator, you should check this. But I'm not going to take the time in the video to check this. So my two solutions are 1, subtract the square root of 3, and 1, add the square root of 3. Remember, all solutions for equations must go into set notation. Now, what would it look like if I had one that did not have a 1 as a leading coefficient? I could show you on a side note over here, because these notes, I go by the book, what's in the book. So if my example were 3x squared, subtract 2x, subtract 3 equals 0, you would have to first make this become a 1. And the only way to do that is to divide by 3. But you can't just divide this by 3. You have to divide them all by 3. So this becomes x squared, subtract 2/3 x, subtract 1 equals 0. Now I have a leading coefficient of 1. I can boot my constant to the other side. This is x squared, subtract 2/3 x, equals now positive 1. Now I have to add some square to both sides. And this is where sometimes students don't like this, they don't enjoy this. But really, if you're taking half of a fraction, all you do is multiply the bottom by 2. Half of 2/3 is 2/6. And you can leave it like that, because you're going to square it. 2/6 is 2/6. Okay, let's write it over here. Half of 2/3 is 2/6. You could simplify it if you want to. 2/6 is 1/3. But you're not done, because you have to take 1/3 and square it. 1/3 squared is 1/9. This is the magic number that you're adding to both sides. Okay, there it is. Now this, how do you get this? Well, it's always going to be a single binomial squared. And 1 is really 9 over 9. So 9/9 plus 1/9 is 10/9. Don't make this harder than it is. These fractions are not that terrible to work with. I take the square root of this, I get x. I take the square root of this, I get 1/3. Signs are the same, right? There's two of them. That's why we do this quantity squared. They're both subtraction. Okay, and then I'm going to take the square root. So I got x minus a third equals plus or minus, you know, the square root of 10 is square root of 10. I can't simplify it. The square root of 9 is 3. Okay, so I did the square root and the quotient rule at the same time. For these, if this would not be a perfect square, you would have to rationalize the denominator. So all these skills come into play. And then I'm going to take the 1/3 over. So x equals positive 1/3. Add or subtract the square root of 10 over 3. Okay, so not too terribly difficult, but it is a lot of skills that are involved in order to do this correctly. Okay, so again, if your answer is not matching the one in the back of the book, it's because if you have a root 2 in the bottom, you do have to rationalize the denominator. So keep that in mind. All right, let's take a look at side 2 of the note sheet, which is now going to be talking about the quadratic formula. Students do like the quadratic formula more often than not because they like what I call plug and chug, which technically we never plug things in. It's called a substitution. I'm a big proponent for correct vocabulary in mathematics, but for lack of a better saying, it's plug and chug. You know, students like to substitute things into the quadratic formula and then just do the computations, which sometimes they don't do the computations correctly. Like when they square a negative, they keep it negative. And so that's going to mess up the whole entire answer when you do that. So this part here says solving quadratic equations using the quadratic formula. And in your textbook, I would like you to read this thing called deriving the quadratic formula. I will probably at some point go through that, and I may give you a pop quiz and just ask you to derive the quadratic formula. So keep that in mind. You may be asked to do this on a test or a quiz. Every year since I've been doing this, I did have the students do this. And again, I would in class. Now, online people, it's going to be difficult for me to not know if you're just reading it right out of the book and copying it. So that's probably not going to apply to you. But having said that, it doesn't mean that it's not going to ever apply to you. So, what is the quadratic formula? Well, if you recall from Algebra 2, x is equal to the opposite of b plus or minus the square root of b squared subtract 4 times a times c, all divided by 2a. Now, I do have a little picture of the quadratic formula. And so on the day of a test or a quiz, I may put this picture up for you. This is the quadratic formula in picture representation, if you will. Okay, so notice this. These are b's. Bzz, bzz, b's. This got the stinger sticking out. Here's my negative b plus or minus. Look at the shape of this b. It's square. Okay, so plus or minus the square root of b squared minus 1, 2, 3, 4. 4 aces, or 4ac, all divided by this large airplane. And if you look at the airplane, it's saying TW subscript of O, there's your 2A. Now, years ago, there was an airline called TWA, and that's why it's an airplane. Okay, so one more time. Negative b plus or minus the square root of b squared minus 4ac, 4 aces, over 2a. Okay, so I will at some point give that to you on a test or a quiz so that you have the quadratic formula. Technically, you should memorize it, but if not, you at least have that to fall back on. Now, we're going to do one example, solve using the quadratic formula, and then we'll be done with today's video lesson. All right, x squared, subtract 2x, add 2. Equals 0. All right, it says solve using the quadratic formula. Folks, you got to make sure everything is on one side, okay? You must have this in general form. Okay, then you're going to identify A, B, and C. All right, the general form of the quadratic is ax squared plus bx plus c equals 0. So in this example, the value of A is the coefficient of the x squared term, or my quadratic term. The value of B is the coefficient of my linear term, -2. And the value of C is my constant, +2. But they all have to be on the same side. So A is 1, B is -2, watch your signs, and C is +2. All right, into the quadratic formula we go. This is the opposite of B, plus or minus the square root of B squared. Subtract 4 times A times C. I highly recommend you do what I'm doing and use a parenthesis template. If you don't do that, you put wrong things in there, and I don't know what to say. You get it wrong. There are too many students that are not successful with the quadratic formula. That's why I'm not a fan of it. And then, 3 years from now, are you going to remember what the formula is? Probably not. -2, right? This is my B's. B's is -2. This is an A. That's an A. A is 1. And this is my placeholder for C, and that is +2. All right. The opposite of -2 is +2, plus or minus. Square root. Now, when I square a negative, it's positive. 2 squared is 4. Now I'm going to multiply these three things. 4 times 1 is 4, times 2 is 8. It's negative. Right? If you have an odd amount of negatives, the number is negative. There's only one negative. Negative times positive, negative times positive, still negative. 2 times 1, 2. Equals, I have to simplify this, 2 plus or minus the square root of 4 minus 8 is -4. Notice, that's not a real number. Over 2. I'm not done because I have to simplify this. 2 plus or minus. That's going to come out as I, which means this is I times the square root of 4, or 2I, over 2. A plus BI form. This is 2 over 2 plus or minus 2 over 2 times I. 2 over 2 is 1. So x equals 1 plus or minus 1I, or just I. I'm going to put that solution in my set notation. I know they're not real numbers, but that's okay. Those are my imaginary roots. And what does that mean if I have I? I'll give you a moment to think about that. Well, if I have an imaginary x-intercept, that means the parabola does not cross through the x-axis. Now, let's look at the original function. It's positive. The parabola opens up. So since the parabola opens up, we must be somewhere on the coordinate plane above the x-axis. It's never going to pass through it. Never, 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 never going to pass through this. Okay, I don't know. This is not the proper graph for this. I'm just, illustrating that when you get I, something like this is happening. Okay, when you see I in your solutions, it means there's no real roots and the parabola does not pass through the x-axis. Okay, so we'll write that. This means there are no real x-intercepts. Okay, it's not passing through. All right, I believe there is a small book assignment that goes with this. If you have any questions, you know what to do. And, contact me. Please advocate for yourself. With this hybrid learning, I know it's hard, but you do have to advocate for yourself so that you're getting your questions answered and that real learning is taking place. Okay, have a great day.